At first glance, a tree looks simple. It just stands there. But hidden inside, that quiet trunk is one of the most powerful hydraulic systems in nature. Every day, tree pulls water from more than 100 meters upward, higher than a 30-story building. Now, here is the weird part. If we try to do the same thing with a suction pump, it would fail at around 10 meters. Beyond that height, the pressure drops so low that water should start boiling. And yet, trees somehow ignore this limit. Today, Omniscient explore a simple question with an extraordinary answer. How do trees lift water far beyond the limits? The story begins underground. Tiny structures called root hairs explore the soil like microscopic fingers. They are incredibly small, but there are millions of them. These microscopic extensions dramatically increase the surface area of the root. They explore the thin films of water surrounding soil particles. The soil usually contains more available water than the interior of root cells. Water naturally flows inward. Once inside the root, the water enters the tree's internal transport system. Inside the stem, bundles of microscopic tubes run vertically through the tree. These bundles contain tissues. The tissue xylem transports water upward through the roots. Most of the cells that carry water in xylem are dead. During development, they lose their internal contents, leaving behind hollow tubes. These tubes connect end to end. Together, they form a continuous pipeline that stretches from the roots to the leaves. Water molecules are unusual. Each molecule has a slightly positive side and a slightly negative side. Because of this, they attract each other. Inside the xylem, this attraction links billions of molecules into a continuous chain. Think of it like a microscopic rope made of water. Water also sticks to the inner walls of the xylem vessels. This prevents it from sliding downward. Together, cohesion and adhesion stabilize the entire system. Pull one end and the entire chain moves. But what is doing the pulling? Surprisingly, the pulling force starts in the leaves. On the underside of every leaf has tiny pores called stomata. They open so the trees can absorb carbon dioxide for photosynthesis. But when they open, something else escapes: water vapor. This slow evaporation is called transpiration. And this tiny loss of water creates a negative pressure inside the xylem. In other words, a pull. Now remember the limit we talked about earlier. Under normal conditions, the system stays stable and air bubbles are rare. It's balanced. But during drought, that balance begins to break. The soil dries out. Water becomes harder to pull. So the trees must create even stronger tension, stretching the system to its limits. Because water molecules hold tightly together, the column can stay intact even under extreme stress. And sometimes tiny air bubbles form inside the xylem. They block the pathways. The continuous column breaks, not boiling, but to form cavitation. If it spreads, water flow stops. Branches begin to die. And in extreme cases, the entire tree can collapse. But trees fight back. They close their stomata and also slow down photosynthesis. And deep inside the stem, they use stored water. During the day, they draw from these reserves. At night, they refill. A quiet cycle of survival. We spent months researching and crafting this video. If you made this far, A small support goes a long way in helping us continue